This is a Thor News presentation. Thor News presents Comet C2012 S1 ISON and WTF Earth. Seriously, bro. Part 45. Wings? Oh, shock. How big is this thing? I am the pseudo-astronomer that is so awesome I floss with string theory. Hey dude, or dudette, sir, or ma'am, do you happen to know how big Comet ISON's nucleus is? You see, my name is Thor, and I have a series called Comet ISON, WTF, NASA Dash Earth, question mark, question mark, question mark, asterisk. And now, on the 45th episode, we still don't know how big Ison's nucleus is. Past Jupiter, past Mars, past Venus, head to the sun by Mercury. And I keep seeing in official respected reports that we still don't know how big the nucleus is because it is hidden behind a hazy field of dust. Well, that's interesting. Maybe I overestimated technology. How big is it? That is what she said. Yeah, that's what she said. Shouldn't we have some idea how big it is? I mean, I might not be some rootin' tootin' highfalutin' professional astronomer who gets all the astronomer groupies, but I would think if I ever saw a bird, or at least the wings, I'd have an idea of how big the breast of the bird was. Haven't we been shooting Ison in the different light waves? Don't we have any idea? When will we know? When will we get the really good photographs of Ison? That is what I would like to know. And over at the... Alright, you may be confused as to what is causing the wings, and science defines it as bow shock. And what I'm saying is, you would think from the wings to the bow shock, you definitely figure out a decent estimate of how big the object is. Anyhow, the reason I'm asking this question is because I'm looking at the bow shock. Can you figure out how big it is from the bow shock? I think so. Or it's just a bow shock uniform and symmetrical, so you can't. Can't you measure the wings to figure out how big the bird is? That's what I'm saying. We're talking about snowball wings, so it is really confusing. I hope you don't mind if I try and fly with this one. Don't hesitate. In the thick of it all, Comet ISON grew wings. Now, earlier on Thor News, we reminded you that science defines comets as dirty snowballs. And we reminded you that Thor News, define comets as magic angels. Well, Comet ISON has grown wings. Let me ask you, does a snowball have wings? No. Does a snowball have tails? No. Do dirty snowballs have anti-tails? No. Do dirty snowballs glow? Yes, but only if they're made from Fukushima snow. And over at the CIOC, Comet ISON Observing Campaign, the flood of new images and surprising changes in appearance in Comet ISON have slowed since yesterday's update. This isn't because everyone has suddenly stopped caring about ISON, but because it is getting harder and harder to image. As of this writing, ISON is only about 25 degrees from the sun, meaning it can only be observed in twilight. Even worse, there's a nearly full moon up at the same time, making it very difficult to get the kind of detailed images like we saw over the weekend. Here's good news. While the Earth-based images are slowing down, space-based imaging is just getting going. And the next week should yield a trove of fascinating and unique results. Messenger is scheduled to observe Comet ISON right now from its orbit around Mercury. But due to the constraints in getting the data back, we're going to have to wait a couple of days. And this is what's cool. ISON should also make its long-awaited appearance in Stereo A's H1 camera tomorrow, although it will be a few days before the images get transmitted back to Earth. Next week, things get really interesting when ISON passes through numerous other cameras, 8 in total, on Stereo A, Stereo B, Soho, SDO, and beginning on November 26th and going through until November 30th. Now that is exciting. If you like it and you want to put an octopus and cameras on it, Octopussy, that's from James Bond. And this is really interesting. We will leave you with one final tidbit for the day. For those of you who remember C-2011 W3 Lovejoy's beautiful sun-gazing passage in December 2011, Lovejoy had an estimated total magnitude of about Mag 10 when it was 8 days before perihelion, and went on to reach approximately Mag negative 3 at peak. ISON is now 8 days away from perihelion and is estimated to be around magnitude 4.5. Carl's not going to speculate on what that means for its peak brightness, but note that ISON is about 100 times brighter than Lovejoy was at the same distance. To sum it up, with today's TLDR, it has been a relatively slow day for news reports on ISON. Well, that's interesting. So, doesn't that mean Kansas times the size by 100? How big was Lovejoy? Let's kick on over to the Wikipedia. Yes, apparently Lovejoy was pretty beautiful, bright, big and long if you were in the right place, right spot. A small companion comet was detected in several images on the 14th of December by Jean Jou. That's interesting. Before perihelion, the nucleus of Comet Lovejoy had been estimated to be between 100 and 200 meters in diameter. Since the comet survived perihelion, it is thought that the nucleus must have been larger, perhaps up to 500 meters during the coronal passage. Wait, so it's 500 meters times 100. Oh, so that means that ISON's nucleus might be up to as large as 500 kilometers? That would be definitely way off the mark of the 3 to 5 kilometers that I've been hearing so often. But maybe size and brightness don't correlate directly together. Or maybe my calculator's broken. Maybe I'm dreaming this whole thing. So if it's 100 times brighter at the same distance, wow. How big is this thing? See, I tried to figure it out myself, and I just killed. It's okay, though, right? Even if it's 500 meters, it's not gonna do nothing. Okay. Science just told me no matter what can't hurt me, right? It can't hurt me. It can't hurt me. It can't hurt you. It's just called icing. Okay, so I guess my range is going to be taking all the data in. It could be anywhere from 3 kilometers to 500 kilometers. Alright, ladies and gentlemen. So I don't really know how big the nucleus is. Maybe you can tell me. That's what I'm looking for. The size. I mean, it's got bow shock and wings. Seems like it's pretty big. And when you look at the bow shock, looks like it's pretty big. I don't know. I'm asking you, dude. Do that? Alright, ladies and gentlemen. Bow shock time. Do the bow shock dance. Bow shock. Bow shock. Well, what is bow shock? I would have said, well, what is wings? But that would have sounded dumb. Hey, you're asking, what is bow shock? Well, let me tell you all the boring stuff right now. A bow shock is the area between a magnetosphere and an ambient medium. For stars, this is typically the boundary between their stellar wind and the interstellar medium. In a planetary magnetosphere, the bow shock is the boundary at which the speed of the solar wind abruptly drops as a result of its approach to the magnetopause. Thank you, Wikipedia. Hey, somebody needs to update Wikipedia. It'll happen to mention comets and bow shock. Man, so I was pulling down bow shock photographs, and they were mostly stars or planets or boats, bow shocking, bow shakalaka, bow shakalaka boom, alright? And over at the Huffington Post, Science, the beautiful Allison Winfield Burns discusses poetically what a bow shock is. A bow shock is a lovely curve of water that fronts a moving forward ship in the ocean. You can also see bow shocks in front of swimming swans and ducks. Or just move your hand strongly through still water and get a shock wave. Front, it's a rippling wave in plasma in interstellar space as our sun races forward to the universe, dragging us all along in tow. There is a big plasmatic magnetic shock wave in front of the sun, kind of way out in front, because the stuff that exists inside of our solar system meets full slam into the other different stuff that is outside of our solar system. Wait, you mean they have different kinds of stuff in other solar systems? You mean like different kinds of Starbucks and different kinds of sports utility vehicles, different kinds of smartphones, and smartphone covers to protect your smartphone? Wow, I would love to see that other extra solar system stuff. I'm glad Santa Claus doesn't live in another solar system, or taking him a long time to get here. And over at the University of California, Riverside, the Institute of Geophysics and Planetary Physics, they got an article that says the large scale solar wind. What happens when the solar wind collides with obstacles such as planets or comets? The existence and nature of a bow shock depends very much on the nature of the obstacle. Planets with no or a very weak magnetic field, but with an atmosphere, such as Venus, develop an ionospheric current sheet that, like the magnetosphere, excludes the solar wind and leads to the formation of an upstream bow shock. If there is no atmosphere, such as with the moon, the solar wind will crash directly onto the surface, gently eroding it and being absorbed by the surface. In this case, there is no shock. And finally, comets, too, can have a bow shock, but it is rather different in character. Close to the sun, the comet nucleus begins to melt, causing the emission of large quantities of neutral particles, which can travel upstream ahead of the comet into the supersonic solar wind. Photoionization, that is, ionization by solar radiation, or charge exchange with solar wind ions, creates a new population of slow-moving ions that are accelerated by the solar wind motional electric field. Back in 1974, they took this picture of Water. I guess it had a bow shot. The emission of neutrals and subsequent creation of pickup ions creates an extended obstacle, which can then sometimes lead to the formation of a cometary bow shock. Alright, this one's been fun. This one's been great. Thanks, guys, for watching. And I can't wait to get an answer to this question. I believe I've been waiting about 8 months. Excellent. Peace out. God bless.